Hello, how you doing today again? Welcome to another episode of Ubuntu and Open Source. I wanted to do a new baseline testing, but I'm going to use Ubuntu, and I'll tell you why in a minute here. So I have CPU-G here, and it tells us some things about my hardware here. It's an Intel Core 2 Dual, and it's the motherboard's manufactured by Dell, and it shows the memory in here and it lets us also know the more about the system here, that it uses Linux. It's the LXDE with open box. And it shows here also that I have an NVIDIA card installed here. And some information here about storage. Well, to me, though it gives us a lot of information here, to me it's not enough. So here we have iNIC. Now, iNIC here shows us enough, well, actually quite a bit of information. Whether it's too much or not enough, that's up to you to decide. But you can see it also shows us Intel Core 2 Dual. But it also gives us the model of the Core 2 Dual, the E6550. And it shows us that it's running at 2.33 gigahertz. And it tells us some information about the cache here, the CPU ID, and the flags. So there's lots of information here with iNICs. iNICs also has detected that I have an NVIDIA card, an 8400. Also shows us the screen resolution here that I have it set at currently, at 1920 by 1080. Then we move over here to the motherboard. Now, to me, this is quite a bit helpful for those who want to do hardware upgrades. Not only can you get into your BIOS and get the same information, but also here with software with iNIC. It too says this is a Dell. From Dell. The BIOS version is 1.0.3. The BIOS date was July 12th, 2007. So you can see this is a 10-year-old computer already. And it has a chassis tag here also saying Vostro 200 and a product name of Vostro 200. So we get quite a bit of information with the iNIC. It shows the built-in audio here of Intel HDD. Some drives. The drives here. It talks about the drives here too. Even gives us it's a scan disk at 120 gigabytes. So we get lots of information here with iNIC. Also here for the system, it shows I'm using Ubuntu, or Ubuntu LXDE 1604. Shows us the kernel version. Shows us the RAM here that's currently installed, and the usage and the swap. I do have 4 gigabytes in here. Shows us the network card here, some USB information here. I just wanted to go over that. Showing the hardware here that I have installed currently. As I said earlier, I want to install a new PCI Express card for USB 3. So system information here. This app I'm showing because it has the same information, but not enough like the iNIC does. Same CPU information here, the display, audio, and the disks. The operating system here, and the name, the kernel modules, which is quite a bit of information. The boot logs here, language, file system, the display, some environment variables, users, processors, the RAM, all that. But what I want to do is get down here to the benchmarks. This is going to be part of my baseline. The current system as it is of the USB data transfer versus the USB 3.0 data transfer in my storage drive, the 3 terabyte storage drive you see up here. And the also the difference in the benchmarks for the 2.33 gigahertz processor, which is current right now, and how much difference will it be when I install a 3.33 gigahertz processor. So here's this test. It's called the Blowfish. And for this machine, it says the results lower is better. Now, everything in my baseline is going to be based for this machine. And then later on, I'll compare it to this machine again, but with the 3.33 gigahertz. I'm going to do them all here. So in this machine is 14.3, go back here, 0.43 seconds. It says results back down here in the bottom, results in seconds, lower is better, 14.3 seconds. This machine compared to Intel Celeron processor would have been 26.19 in a PowerPC 200 megahertz. 172.82 seconds. But my main focus is this machine. So, and with this here, after I do all these, I can generate a report and save it. And then I'll be able to pull it up again, show you the results with the 3.33 gigahertz processor. So this here crypto hash test has 101.22 seconds. Higher is better for this one. And we have this here test. This machine again is 5.17 seconds. Lower is better. 8.14 with the Celeron processor, and the PowerPC version 58.08 seconds. I'm going to go through all these. Exactly what these tests are, I have no idea. But they're there, so I'm going to use them all so I have a baseline test to compare the two processors. 12.55 seconds, lower is better. So next time when I do this, I'm comparing it to my CPU clock with this machine, lower is better. Then we have a couple of FPU tests. Now this one, results in seconds again, lower is better, 8.37. The last one here, now this one here is 16.49 seconds, where results is in seconds and lower is better. If there was a Celeron processor, it would have been 40.88 seconds, and a PowerPC would have been 161.31 seconds. And so, like I said, we could generate a report. I'm going to generate a report, and I'm going to do them all. Select all, generate. Hard info report. Pre. Hardware. Baseline. I'm going to call it this because it is a baseline report of some of the hardware features before the upgrade. I'm not going to open it up now. Okay, so that was that test. So I'm also going to do this test also over again in Ubuntu with the disk GNU disk utility. Benchmark partition. Whoa. Okay, here we go. Okay. Okay, right. Okay, remember last time I didn't check this, or I didn't have it checked, so I'm going to check it this time before write benchmark also. Same number of samples, same sample size of 10 megabytes. Same number of samples for access time. So let's go ahead and start that. Put in our password. Now I'm doing this over again because it might be a little different with Ubuntu. So I want to have the same baseline between, Ubuntu and Ubuntu with the hardware upgrades. And this will have a more accurate sample between the USB 2.0 data transfer with the 3 terabyte hard drive and more accurate, testing against the 3.0 USB with the 10 terabyte. With the 3 terabyte hard drive. So that's why I want to do this over again. As you can see, it may be fairing a quicker read with Ubuntu than Manjaro, because if you remember, with Manjaro, the average read rate was approximately 37 megabytes. And I forgot to check the write to sample the write rate. And also the average access time, I think, with Manjaro is like 16 something milliseconds or something like that. So it seems like Ubuntu's average read rate with 100 samples of 10 megabytes is 33.0 megabytes per second. So it seems like this here benchmark has settled on that. And the average access time, it seems, is finished its calculations was 18.09 milliseconds. So now I'm wondering, since there's a 4 megabyte difference in the average read, and approximately 2 milliseconds difference in their average access time, if I should do a few of these. I am going to use LibreOffice Cal here. So, 1, so sample size, read, write, access time, these will always be 10 megabytes. So I can just copy those. Oops. On too many E's and 3. Okay, number 1 has a read rate 33.0 megabytes. A write rate 23.8 8 megabytes. And the average access time 18.9 milliseconds. So let's do another benchmark. Same. We're going to keep everything the same. And I'll do it 3 times. I'm going to do this 3 times. Already, it seems to be showing something here. Even though it's only 34% done, the average read rate seems to be approximately the same. The average write maybe this time may be a little bit higher. We'll find out though. The average read of samples seem to have gone up. Looks like it's done at 33.4 megabytes. The average write seems to be right at 24 megabytes. The average access time, as soon as it's done calculating, it looks like it might have improved. At 18.14. Oh, it went up. So I'm going to do it again. I bet you the third one is going to be same thing. It's going to slow down. Same information. Same 10 megabytes. Looks like both of them in the beginning, within the first few seconds here. Very quick read rate and write rate. But in the end, overall, looks like it's going to slow down. Now the reason for this is to get an idea, a sample rate of the benchmark test itself to compare it to. Because hard drives, you read and write to the portions. And each time it can be different. It read and writes and read and writes. So with at least with 3 samples of doing the benchmarks, we should be able to pull off an average. Now it looks like the average read of 32.7 megabytes per second with 100 samples is faster. The average write stayed the same, just as sample 2. This will help us to determine, with these 3 samples of read and writes and access time, of how much better or different that the USB 2.0 PCI card to access this 3 terabyte hard drive, what the improvement's going to be over the USB 3. In the 18.09. So it seems like the access time by the 3rd sample, it's really increased. Because we went from 18.9 milliseconds to 18.14 milliseconds on the 2nd sample, and by the 3rd sample, we came down all the way down to 18.09 milliseconds. And this read rate, everything except for the write rate, has come down. So again, I will save. We'll call this again So this is, I'm going to label this HDD benchmark pre-hardware baseline. All right. So, thank you for watching, and hopefully when after all the hardware is installed, I do a separate test on the CPU when I upgrade the CPU, and then a separate test for the hard drive, because I'm going to put all the parts in at one time. I don't think it's going to make much difference if I do the CPU and the PCI Express card separately. I don't think it's going to make much of a difference if I do them separately, but the tests themselves will show the system performance being tested against itself to see if it actually is an upgrade to this hardware itself with the same motherboard and RAM. Okay, thank you very much.